Welcome back to AP Statistics with Mr. Walton. We're going to do test review for Chapter 12. So first, let's look at our targets. What do we want to make sure we know? Here they are. You go through this, you read through this, and you say, yes, no, sorta, what? And figure it out. Here's my little helpful hints, your little learning plan. Let's scroll down. 12.1 is all about inference for slope. And that is our B, which is an unbiased estimator for beta. Okay, so we're now dealing with LSRL, the least squares regression line. We're talking about B, we're talking about a significance test or a confidence interval. So that means we need to remember our acronym, LINER. For L, we're going to look at our scatter plot to say it's linear in nature. For R, we're going to say random selection was used, whether it's through random allocation or it's a random sampling method. Then, based on the fact that it's randomly sampled, we can talk about the independence. Okay, we're going to say independence is reasonable based on randomness. Okay, then we're going to use our residual plot to talk about equal variance, to say, yes, this looks pretty good. And lastly, let's use a normal probability plot of the residuals to talk about whether our data is approximately normal or not. And this is the breakdown of our beautiful section 1 for the conditions. Then we have our confidence interval, and it is B plus or minus T critical times SE sub B. Right? So we're going to remember that we've got inverse T, 1 plus confidence level divided by 2, comma, degrees of freedom. Degrees of freedom is n minus 2 here. Remember, SE sub B, our relationship for our beautiful T is B minus beta over SE sub B, so don't forget our shortcut since B is 0, right? And then we use T as our test statistic, and T critical is our critical value. All right. Hopefully you guys remember. We're going to have our alpha levels. All right. And we have alpha, and then we have our p-value. And we have to keep in mind, if p is less than or equal to alpha, we reject H sub O. If p is greater than alpha, we fail to reject H sub O. Remember, we're always talking about H sub O. Awesome. Here we go. Before we move on, the next section was 12.2. Ba-ba-bum. And in 12.2, it's all about regression models. No conditions. No conditions. Which is best? Linear, exponential, or power? Now, linear, that should be our wheelhouse. We should know what we're talking about. Exponential. How do we arrive at exponential? Remember, we're going to talk about x comma log of y or ln of y, which means that it's going to be in the form of y equals a times b to the x power. All right, keep that in mind, log or ln. Power model, please keep in mind for the power model, we're going to talk about log of x and log of y to transform our data, which means we're going to have y is equal to a times x to the b power. Okay? Please keep in mind when we solve for logarithms, we have to go back to our rules for exponents and logarithms on how to manipulate our equations. And our ultimate question is, which model is best and what information can be gleaned from our data once we've established which model is best? Okay, let's move on. Let's practice. A little bit of practice. Yes. Multiple choice. Give you a second. We're looking at this. You read through it, and it says, for number 1, which of the following is the estimate for the standard deviation of the sampling distribution of slopes? So that standard deviation of slopes, SE sub B. Bam. Bam. A is our answer. Okay, still in the same problem. We're looking at number 2. I'm just going to scroll down so we can see all of the choices here. It says the equation of the least squares regression line is, all right, so let's look, let's analyze, let's make this simple. It says up here, I'm highlighting right now, fresh, that's my x. Where do I see fresh as an x? 1, 2, 3. That means no and no. Okay, next up, what's next to fresh? 0.5304. Guess what? This is my slope. Where do I have 0.5304 as my slope? Here and here. That means no. Okay? Where is my y-intercept? Okay? Hey, it's right here. Where is 1.6310, the y-intercept? Only right here. Therefore, our answer is D. Boom. Here we go. Number 3, you got to read through this. Sorry. There we go. Okay. Pause it, read through it. Then we're going to look, and then I'm going to make a little slight change because we're talking about a one-tailed test. What does that mean happens to our p-value? 0.026 divided by 2 is equal to 0.013. So I'm going to argue that all of these p-values should be half of what they are. So let's pretend that 0.02 and 0.026 are equal to 0.01 and 0.013 so that we can answer this appropriately. All right, if we do so, then E is the correct answer. All right, we're moving. For number 4, you're going to read through it then. Which of the following conditions for inference does the residual plot suggest has not been satisfied? Now, we're talking about a condition. So, has not or has, when we talk about residual plot, I should be thinking of equal variance. Which one of these best talks about that? I think it's Captain Obvious. C. Bam. Moving on. What does R² represent? Remember? The percentage of variation that can be explained by the regression. So we are talking all about D. Which of the following is the 95% confidence interval? Okay, so we know we've got no and no. It's got to be here, 0.5254, all right, and then we need to make sure that we calculate a correct T critical, which is 2.048 this time. Bam, D, D. All right. Suppose we're looking at number 7 and number 8. It says, aha, log, log, power, 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 power. What do I see? Power, C. Okay. Then what do I have going on here? Is this a power model or an exponential model? Okay, so we need to recognize this is exponential. So that means just a log of y versus x. Where do I see that? Ah, I think again it's C. Boom. Here we go. Moving on. Number 9. All right, they're asking us again, which of the following best describes the model that is given by the computer printout? Now, look, ln means that's a natural log. No ln, so I have a log of y, internet users, which means just that, so that means it's exponential. Which one of these says exponential? D or E, so bam, bam, bam. Which one has users? Bam. It's the ln. ln means log base E, so it's D. Okay? Then we're looking at number 10. We've got all this. We're reading. Pause it. Then we're coming down here. Okay? And for this one, they're actually asking us to calculate. And we have to create our equation. We have the ln of y hat is equal to 6.3324 minus 0.6513 ln of x. So then let's do that. Let's solve it. 6.3324 minus 0.6513 times the ln of 250, which means I get the ln of y hat is equal to 2.736, which then means y hat is equal to e to the 2.736, because ln is log base e, which is approximately 15.429, and that's a percentage based on our context, which means our answer is B. Boom. All right. Which model is best? Okay, you guys try it and use years since 1980. All right, so we make a scatter plot. We have number of cases versus years since 1980, and that's right there in front of us. So let's move that back up where it belongs. All right, and then we need to take our original data and check. We have our R-squared for linear regression, R-squared for exponential, and R-squared for a power regression, and power wins, so I make a residual plot based off my power regression, okay? Once I do that, I have one more thing to say. I have all the components. I have scatter plot, residual plot, which model is best, so I come back over and I look up here, I say, since my residual plot is random and the R-square value is highest, I will use the power model. And then I would say oops, not X, sorry. Here's my model. Bam. Don't forget to go back over your graphic organizer because it's rocking and a rolling. And good luck!